Language models have been really popular lately. We have OpenAI, we have all of these cool chatbots. You can automate gaslighting your friends. But how do we actually make them do things that are useful? And more importantly, how do we make them do something outside of the text box? So this is where the concept of function calling comes in. Function calling is a way to have the language model interface with the outside world. Typically, the way it works is in your language model prompt, you tell it you have such and such functions available. This is how you call them. Then the language model will attempt to generate the text saying, here, I want to call a function. Your code then stops it, runs the function, gives the result, and the language model can resume. So here's how you can do that in practice. So I didn't do any slides. We're just going to do some live code and demo. The first part is the prompt. So I'm making use of a tool. Is this legible? Okay, excellent. So I'm making use of a tool called Ollama, which is a way to run small, large language models on your computer. So everything I'm running is entirely on this little thing here. So what we have here is a particular model I'm using. It's based on, it's really hard to read name. It's, let me see, it's FC Dolphin 2.6 Mistral 7B DPO laser, the GGUF version. So this is a model. There's a group called Cognitive Computations, and so they release these open models called Dolphin. And so this particular one they released recently, which is trained on a data set for function calling. So instead of having to trick your AI into doing something specific with a prompt, they pre-trained it with some data. If you go to my GitHub repo, which I'll post on Discord later, you can see the details. So what we're doing here is we're saying we want to load the model. For the template, we're going to use a conversational style template for interacting with it using a standard format called chat.ml. And then in the system prompt, we're just telling it you're a helpful assistant, and we're going to teach it that it can invoke this search Wikipedia function. And the training data sets, they taught models how to invoke functions by using this JSON format for describing it and a JSON format for running it. So here you tell it the name of the function, the description, the various attributes that you can pass to the function to invoke it. And then over here, I added a little bit more prompting saying, you gotta call the functions, because sometimes if you don't, the model's just like, you know what, I'll just make it up. I don't need to actually search Wikipedia. I am Wikipedia. So let's look at how to instrument it. So the way you want to actually run the model is you want to do a pass of first querying the model, seeing if the model is trying to run a function, optionally running the function, and then getting the model to give the final response to the user. So in order to make that work, you need to build up your context window over time. So Ollama, it can run the model, and it has this fancy feature called chat, where it'll just automatically set up the chat interface for you. Don't use that. It doesn't work. Manually set up your prompts, and that way you can do things that the default templates can't do it. For example, if a model refuses to do something for you, you can just modify your response prompt and be like, assistant, : yeah, I can do that. Here, let me search. And you can make models do whatever you want if you get outside of it. Don't use the chat prompt. Make your own thing. So over here, what we're going to say is every time we do inference on the model, we're going to generate the entire history, where we take that series of messages from the user and from the assistant, and we're going to concatenate it in a large string. And then we're going to generate a response from the model. Anyway, so let's go up to where I'm actually doing the invocation. What we're going to do is we're going to first start with a message to the AI with the user's prompt. So for example, what is the capital of Ottawa? And then we're going to generate an answer for that. More likely than not, the model will attempt to perform a function call to search Wikipedia. This is a bunch of parsing code. Doesn't really matter what it does. But over here, I take that function, and now I invoke it. So I have a map up here. Sorry if the live code is hard to follow. I have a map of the function names to the actual function implementations. So right now I just have the search Wikipedia function, but this could be a search my corporate wiki function or send an email or whatever else that you'd want a language model to automate. I'm just using the open API that Wikipedia provides for searching for text snippets, and I'm limiting it to just the first 3 most relevant snippets for a given query. So next, after I get the function response, I'm going to inject a message into the context where we have the function call the model tried to do and the syntax with the response of the data. Then I take that final answer. I'm going to see if it's another function call, I'll invoke it, else I'll return it to the user. Okay, that was a bunch of code. Let's actually look what it does in practice. So what I'm going to do is I'm going to just run the model. It's going to take a little bit of time to boot up, I think. Has it? Yeah. Oh, wow, it's really taking time to boot up. One sec. Oh, my God. This is the downside of live demos. All right. When in doubt, restart everything. Okay, and... Okay, excellent. So that was instantaneous. Oh, I couldn't see my character. Okay, so I'm going to ask my model a question like, what is the capital of Ottawa? And then I'm going to hit enter to actually invoke it. So you might be able to hear, well, my computer is heating up immensely. It absolutely hates trying to run models. If we check out my system monitor, we'll probably get to see all of my CPUs finally being in use. Yeah, so all of my threads are kind of spiking up, trying to load the model into memory and actually execute it. So what's happening right now is it's parsing the model information and loading it into memory. I don't have the drivers for GPU acceleration, but if you have a GPU, you can speed this up significantly. So here it did the initial generation, and the model gave me back a function invocation saying, hey, I want to search Wikipedia. So my computer now took the search results and plugged them back in, and now it's doing another round of trying to generate the final response. So right now, if you ask a model what is the population of Ottawa, it can just make up a number. And honestly, if your model was trained recently, that might be good enough. However, what if it wasn't trained recently? Or what if you don't have the money to train a model every time your information updates? With function calling, you can have on-demand retrieval of information, and you can use the language interface more as a way for users to kind of program your information system without having to actually program it. Oh yeah, it's really heating up. Sadly, I don't have a fancier computer, otherwise this would have been faster. If you have a Mac or anything with an M3 chip, it's actually almost instantaneous. Oh, here we go. That's brutal. Oh, I said, what is the capital of Ottawa, not what is the population? Oh my God.
So is it written in Wikipedia? I thought I was going to say Toronto.
Oh my God. Yeah, so what happened is it actually queried Wikipedia for capital of Ottawa, and it probably got capital of Canada is Ottawa. Oh my God. And then it summarized the data. I kind of commented out some of the output because it's just completely illegible. But over here, I can ask it for the population, and then hopefully this time it'll run faster. Yeah, it's chugging. Let's look at I really love watching the models work because it feels good to make my computer actually do some computation that's not just Google Chrome. So a pro tip, if you're running local language models on a computer you're trying to use, make sure to limit the number of threads to at least 2 less than the number of threads you have. Otherwise, it'll lock up your GUI. Your computer will just become a brick for a while. If you're lucky, it'll unlock when it's done inference, but honestly, just don't use all your CPU threads. Yeah, sorry, it's,
Can you wrap it up with the
yeah. So it did the function call, it's summarizing, but let me just quickly run another model in parallel. I guess I just love to suffer. So there's a model that's really, really tiny called Tiny Dolphin. I think the model itself is like less than 2 gigs in size, and it's really speedy, but it's also very dumb. So we're going to try to compare what Tiny Dolphin thinks the population is with what the Wikipedia-enabled model thinks the population is. Yeah. Usually it's faster with power. That help? Yeah, doing local inference, I wouldn't recommend it. All right, well, I'm not going to waste your time, but basically, if you have a more powerful computer, or if you have a smaller model, or if you have smaller bits of text that you're working with, you can get it to invoke any sort of search and process any sort of data. What I want to get at here is Wikipedia is an easy target for searching, but this could be something like controlling home automation or security systems or whatever else. With these pre-trained models, you can have on-premises hardware that doesn't cost thousands and thousands of dollars and needs to be replaced periodically. You don't need to have the latest and greatest model. What you can focus on instead is your available data and your business use case. Yeah, demo didn't work, oh well, but come by, find me somewhere, and then I'll show you the working version.